So for this tutorial I'm taking the project Cobra, which is a table lamp that uses LED technology. When making a project for SLS, at the end we will need a 3D file which can be transferred to the machine in order to laser sinter the object that we require. You can either model it in some sort of foam or any other material and digital scan it, or as we do right here, we can model it straight up in 3D. We've drawn all the different sections and used the loft function, then create cavities for the head for the LED lights, and now we are creating the foot and the base, which hosts the cavities for the electrical system, the channel through the neck, that is for the cable, and there we can see the lid, the electrical lid that has been made. So at the end we end up with a complete digital drawn 3D object, which can then be exported into a format SLS, the STL format, which can be used. The program of the machine will divide it in different layers that we can see here, which will make layers of 0.15 millimeters, and the machine will then reproduce that, spraying a layer of powder, nylon powder, and then only sinter laser on that level what needs to be solidified. And then we end up with a complete block of powder, of nylon powder, where inside the piece is hosted. Here we can see the actual computer that drives the machine and the different sections that are being laser sintered and that he needs in order to build up that complete 3D piece in nylon. The machine sprays a small layer, a very fine layer of powder, of nylon powder, as we can see here. That layer gets heated up to about 170 degrees, which is then, that is just before melting point, 170 degrees, and you can see that here. And the laser then just tips that melting point on the places that it needs to laser and it needs to sinter. So here we have the complete block. Of course there are many more projects in one block, as the program and the process completes always the same block. It is economically beneficial to put as much pieces inside a single block. So the LED light, the Cobra LED light, is somewhere in the base. We can see that here. When the block is put on its side, we can see here the neck sticking out from this block, and that needs to be broken out. So the powder then needs to be removed and the solidified pieces need to be taken out. The powder is quite dense, so if you have cavities and small spaces, like for example the channel that we made through the neck, it is quite difficult to get the powder out. So that channel was only 3 millimeters by 5 millimeters wide, and it makes quite a curve through the neck, and it was very difficult in order to get that out. Maybe in production it's not feasible to spend that much time getting the powder out, so probably for other pieces we will widen that section. Here you can see that the piece comes out with everything that has been drawn in 3D. So all the studs and pieces for holding the electrical devices are all put in place and come out perfectly as drawn. It is a very creative, and here we can see different projects all made by Selective Laser Sintering SLS. They're all in nylon, and you can see that almost any form can be can be made. Because the powder supports basically the whole structure at the moment it is built, overhanging pieces or non-supported pieces can actually be made. It's a very exciting process. Here you will see a ball later on that would otherwise be almost impossible to be made by normal manufacturing processes. This is that's the ball that you can see there. That are basically balls within balls, and it's all seamless, and it's something that would be almost quite impossible to do by any other process. So even complete joints, rotating joints and other types of joints, movable joints, can be immediately created within that process. Comes like this, ready-made out of the machine. Because it is a self-supporting system at the moment, it is created. It is possible to create complete moving parts. As for example here, if you make a sculpture or a model, you can 3D scan this and then have this perfectly reproduced in nylon and in SLS. This is another process. It is 3D printing. It's a starch with epoxy bounding, and the advantage is that it is cheaper than selective laser sintering, and you can build color right in. So you can print this right in 3 dimensions, completely colored. And you can do the same actually in metal. This is stainless steel. It's a much more expensive process, but it's also a very exciting process. It can be completely built up the same way as you do with selective laser sintering. This is metal laser sintering, completely built up out of stainless steel. So that's it for this tutorial. I hope you enjoyed it.